സ്ക്രീൻ സ്റ്റാർട്ട് ചെയ്ത് കേൾക്കുന്നുണ്ടോ?
ഇല്ല ഇല്ല.
ലൈവ് റിഫ്ലക്ട് ആയിട്ടുണ്ടോ?
എന്താ?
ലൈവ് വന്നിട്ടുണ്ടോ ഇങ്ങനെയൊക്കെ?
ഒരു നോക്കട്ടെ.
ഓക്കെ. ഓക്കെയാണെന്ന് തോന്നുന്നു.
ലൈവ് വന്നിട്ടുണ്ട്.
സോയിയുടെ സൈഡിൽ എനിക്ക് ഇതുണ്ട് കേട്ടോ, എക്കോ ഉണ്ട്. പക്ഷെ ഇതൊന്ന് മ്യൂട്ട് ചെയ്യുമ്പോൾ ശരിയാവും.
ഇല്ല.
ഓക്കെ. Good morning, sir.
Hi, morning.
Just waiting for the other judges to join us.
Yeah, there is time. So, I'll be kind of leaving shortly, but just wanted to check in.
Good morning, Anand.
Good morning.
Just waiting for the next sir.
Yeah.
The team is already here. They're already in the waiting room.
Okay, no problem. So, Anupam, you are from home today.
Yeah.
Okay. Maybe just give Vinod sir a call so that
Yeah.
he remembers. Yeah.
So, Mahalingam, you're joining from Cochin or where are
Cochin,
you
Cochin.
based? Cochin.
Cochin. Yeah.
All right. Okay, this is Satish.
Yes, sir. Come on.
I just checked with Vinod, sir. He should be joining shortly.
Okay.
So, I see that Vinod is also joined.
Yes, sir.
Yes.
Yeah, so good morning, everybody. So, thanks for kind of joining, and I hope everything was good yesterday in yesterday's call. I will hand over to Vinod right now. He will share the rest of the session. Thank you.
Thank you, sir. Thank you, sir. Anupam,
Yeah.
shall we start? The
Yeah.
candidates? Okay.
Yeah. The candidates are here. I'll just start the recording and give a formal introduction, and then we can begin.
Okay.
Yes, well, welcome everybody to the second day of the final round evaluation of 13 CSI InApp International Student Project Awards. Before we begin, let me shed some light on the entire final round evaluation process. We commenced this year evaluation with over 200 projects and rigorously reviewed them over a period of 6 months, eventually shortlisting 19. The final evaluation takes place over 2 days, with each project team given a 30-minute slot. Within this time, they have 20 minutes for their presentation and 10 minutes for a question and answer session with the judges. Following each presentation, the judges will deliberate considering specific criteria and assign scores to each project. The projects will be evaluated by an eminent panel of 3 judges who are pioneers in their domain. I would like to introduce the judges for the day. We are honored to welcome Mr. Satish Babu, co-founder of InApp and an experienced leader with over 30 years in IT as a consultant, designer, developer, and trainer. He has served as President of the Computer Society of India and Chair of IEEE Kerala section and remains actively involved in organizations like ISOC, ICANN, and IEEE, contributing significantly to internet governance and community development.
Hi, good morning.
Next, I would like to introduce Dr. Vinod Chandra SS, a professor in the Department of Computer Science at the University of Kerala with over 20 years of experience in teaching, administration, and research. He has guided numerous PhD and master's students and has published respected research at the international level. He also manages e-governance projects at both government and university levels and has successfully led several research and development projects funded by various organizations. Additionally, he serves as an industry consultant. I extend a warm welcome to you, sir.
Hi.
Next, I welcome Mr. Mahalingam PR, who previously served as a professor and is now the manager pre-sales at InApp. With a solid background in academia and the IT industry, over the years he has made significant contributions to the field of computer science through teaching and mentoring students. Currently, in his role at InApp, he focuses on driving client engagement and providing strategic technical solutions. His expertise bridges the gap between education and industry, making him a valuable contributor to both fields. I extend a heartfelt welcome to you also, sir.
Thank you.
Finally, I welcome all the viewers and participants to the event. Also, congratulations to all the participants who have qualified for the finals and wishing you all the very best for your final presentation. We have a total of 4 presentations planned for the day. Up first, we have dermatographics as a predictor of intelligence quotient and slow learning rate for college students. This has been developed by the students of Government Engineering College, Barton Hill. I'll be letting the team in right now. Also, judges, please note the project ID for the team is CSIN 2024-0352. All right, so welcome team. I hope I'm audible to you all.
Yes, you're audible.
So some general instructions before we begin the evaluation. I request all of you to keep your videos turned on throughout the entire course of the evaluation. You have a total of 30 minutes for your allotted for your evaluation. You can use the first 20 minutes for your presentation, and that will be followed by 10 minutes of question and answer with the judges. So I'll be taking a screenshot right now. So urge everyone to turn their videos on. We're good to go. Team, you may start presenting. All the best.
Good morning. Before that, I would like to take a moment to make an announcement that one of our teammates has fallen really sick. So we 4 of us will be covering him for him. That's it. I'll just share my screen right away. Can you please give me the permissions for the screen share?
You should be able to do that. Could you just request for the permission? Can you check again? You should be able to share.
I'm working on it. I hope my screen is visible.
Yeah.
Can anyone give a small heads up?
Yeah, this is visible. If you can start.
So, like, I would like to give the, I'd like to move to Shruti. You can start. Thanks.
Good morning, everyone. We are the students of Government Engineering College, Barton Hill, Trivandrum. Here we are with our research project on the topic dermatoglyphics as a predictor of intelligence quotient and slow learning abilities for college students. I am Shruti Biju, and over to the problem definition. Even if the technology is growing very high, if we need to find the intelligence quotient of an individual, there are certain tests. So our main aim is to find an alternative to this, or how we can technically correlate between this dermatoglyphics parameters and the cognitive abilities of an individual. So over to the proposed system. So we can by the proposed solution, we can solve the problem definition in 3 phases. Phase 1, psychological data collection. Phase 2, dermatographic data collection. And phase 3, creating data models and computing using machine learning. Over to the phase 1, psychological data collection. In psychological data collection, we mainly deals with a test named as Rabin's Standard Progressive Matrices. It is a test that we need to carry out under the supervision of a trained or professional clinical psychologist. On over to the features of this test, this is the sample of the test that will be conducting under a professional psychologist. It will be a non-verbal test, and it can be conducted either in individual or group above the age of 5. And there will be multiple choice question mainly for pattern recognition. On coming to the parameters that we will be extracting from this test is IQ score, IQ time taken, and IQ grade. On coming to IQ score, the mark or the score that a particular individual obtained by writing the test, and coming to IQ time taken, the time taken by an individual to complete that particular test, and IQ grade, there are mainly 5 grades, and on the basis of the score obtained by an individual, they will be categorized into different grades. And on coming to phase 2, dermatoglyphic data collection, the main gadget we'll be using is Futuronic FS80 rays. This device is used to take the image of the fingerprint, clear image of the fingerprint by scanning through the device. And on coming to the parameters, this is the sample output that we'll be obtaining while we are using this Futuronic FS80 rays. And on coming to the parameters, mainly there are 3 main fingerprints in the fingerprint of an individual: loops, whorls, and arcs. So how we are classifying them? On coming to the patterns, the region where most of the pattern aggregate will be the core, and the pyramidal structure formed by the curves will be the triradius. So the loops will be having 1 triradius, whorl will be having 2 triradius, and arc will be having no triradius. So on coming to the parameters, other dermatographic parameters, total fingerage count is the total fingerage count that we can be calculated from the total 10 fingers, and absolute fingerage count is the total count of fingerridges except the 2 thumbs, and individual fingerage count is the count of the ridge in individual fingers, and pattern occurrence is the what type of pattern will be occurring in each individual 10 fingers. And after getting a clear image, there will be many image recognition algorithms that will be available in the public repositories of GitHub. And if we are getting a clear-cut image without any breaks or scars, by using this image recognition algorithm, first the image can be converted into a grayscale, and after the grayscale, using that image, there will be other process named as Gaussian blur, and after that they will be only outlining the regions where there are more curves are present, and the curves where more of the curves are aggregating, they will be considered as core, and the pyramidal part will be considered as triradius, and between them how many ridges are there, they will be calculating as the number of ridges. So over to the phase 3.
Morning, everyone. My name is Gokul. Let's move on to the phase 3 of our project. So in phase 3, we were planning to create data models and compute different machine learning algorithms. So our main aim was to combine the psychological and biometric data, which gives us the best result. Out of the data which we obtained, 70% were considered as the training data set, and the 30 were considered as the testing data set. In this training data set, different algorithms were implemented where the best data set having the highest accuracy was considered to be as a final data set. Let's move on to the detailed flowchart of a project. So in the first one, we in data collection, there were mainly of two categories. First one was the in IQ data collection. The second one was dermatographic data collection. In IQ, there were again three parameters such as IQ score, IQ time taken, and IQ grade, which was explained by my friend previously. And also in dermatoglyphics, each of the parameters were calculated in two ways: in image process rich collection and manual collection. After calculating through this method, we again got a list of parameters such as total finger count, absolute finger count, etc., which were also explained in detail by my teammate. So these different categories of IQ data and dermatographic data were combined in 48 different sets of combinations, which were subjected to have different algorithm methods. So, for example, this finger count and IQ were considered as a single set of combination. IQ score and IQ time taken, along with absolute finger were considered as a second set of combination, etc. So, as such, 48 such combinations were extracted, and each of the set of combination were subjected to different algorithms such as linear regression, like decision tree and random forest. And we were the final result was that which data set having all the highest accuracy in all the three algorithms were considered as our final data set. So this is the overall structure of a proposed system.
Good morning, I'm Neeraj. Coming to the implementation is mainly done in three phases. Phase 1 is psychological data collection, phase 2 is dermatographic data collection, and phase 3 is creating data models. Coming to the psychological data collection, we collected the psychological data from almost 212 participants from our college. This is mainly conducted using the Raven's SPM test, which is conducted in offline mode by using clinical psychologists. And this is how we got the evaluation rubrics, and we categorize the students into 5 grades: grade 1, grade 2, and up to grade 5. And sample of result is also shown here, where IQ score, IQ grade, and IQ time taken. In phase 2, the dermatographic data collection, we collected the fingerprint patterns of almost 171 college students using electronic FS acceleration device, and we calculated the rich count using image recognition algorithm and categorized into different 40 different combinations. The 40 different combinations are mainly done using like the dermatographic patterns are then combined with the psychological patterns. Each dermatographic patterns is made in combination with each psychological data, and at last we get 40 different combinations. This is how the dermatographic data collection is done. So this is how the dermatographic combinations of 40 data set is made. In phase 3, creating the data set model. Obtaining the 40 different combinations, we develop using different dataset models such as linear regression, decision tree, and random forest, from which the best machine learning model is identified and from which we calculate the accuracy. Different machine learning models of 40 different combinations are shown in the next slide. Here you can see, for taking the example of dataset 8, here arch count, world count, lobe count, which is dermatographic data sets, made in combination with the psychological data IQ grade. Similarly, 40 different combinations are made. Coming to the workflow of the machine learning model, the fingerprint data, that is the dermatographic data, and psychological data are combined. Machine learning model is prepared and cleaned. After proper feature extractions, the training data and testing data are separated. When multiple regression models such as linear regression, decision tree, and random forest is applied, we calculate the mean absolute error and find the best accuracy from the mean.
Hi, my name is Gautam. So I'm explaining about the technologies. So we have used Python for the programming part, and we have used Pandas, NumPy, Scikit, OpenCV for the machine learning libraries for the machine learning part. For the processing of algorithms, we used linear regression, decision tree, and random forest. And to take in account the OpenCV code or the image recognition that we have used was a complete failure, because all the fingerprint patterns that we have received is completely filled with scars, and the images were out of clarity. So we counted all the fingerprint ridges, all 171 samples. Moving on to the result analysis. We have segregated the data from 171 individuals into 70% for training and 30% for testing data set. And also out of this, each data set we have taken the dermatoglyphics parameters as the test variables which target towards the fixed variable, which is the IQ parameter. And that's how we have done the computational process. And through doing the computation process for all three all three algorithms, we have computed the mean absolute error and root mean square error for each and every data set. And from this, we have obtained the accuracy for each data set under each algorithm and each errors. And finally, we have made a table which is looking like this, and we have found the top three accuracies which comes here. And out of this, we found the best combination which is possible to do the prediction. And the conclusion that we have derived is the data set number 22, which is a combination of total finger edge count, absolute finger edge count, the count of arch, loop, and word patterns is very much related to IQ score, and which is very much possible to give a predict the IQ score with an accuracy of 92.9%. So like we have also verified the same with by manually testing by giving the dermatoglyphic parameters as input. So we were able to confirm the validity of like the verification of this particular machine learning model as so, like moving on to the future scope of this application, it is very possible to develop a more machine learning system that can predict and classify the students of a class based on their learning ability. It is able to predict the intelligence quotient of an individual, and moreover that this is a research area where there isn't much of a research progress is happening. So it is possible to implement more machine learning models, and there is a possibility of building new algorithms that is possible to extract more patterns from the dermatoglyphics, and there is a possibility of making a relation between the dermatoglyphics and the cognitive parameters. So that's all from our side as presentation.
Okay. What are the algorithm, the machine learning algorithm you have used?
Linear regression, random forest, and decision tree.
Why you use the three algorithms differently?
So sir, like we first planned to use linear regression solely, but when we were like, because we had no idea about what is going to happen right at the end. Like, so we were we for a just we want to make sure that it is we are getting a output from all these three models, all three regression models.
If you just go to a workshop, that
Yes.
that is workshop expert will take only one spanner. For example, 10, 12 spanner for removing your screw.
Yes.
Is he take 3 spanners? If he's an
So basically
expert,
the thing
he will
is,
not take.
yeah, I got it, sir. But the thing is that
will choose only one model. That is the correct way. You may experiment. You may experiment or experience with the many models. After finishing this, you can choose one and you can present one. That is the correct way. Okay. Do you think the data set is sufficient? For example, this is highly related to IQ. So IQ related thing. So the data set is, I think, 212 persons, people, data collected from 212. Is it sufficient? Do you think so?
no, not exactly, sir, because there were very difficulties for us to collect this data set. Because since we are involving the fingerprint patterns, there are a lot of ethical guidelines to be followed, and we have done this research or we have done this project as a as to shed light on some darker areas of research, because when we are looking upon this dermatoglyphics and the research areas under dermatoglyphics, we couldn't find anything which is very much involved with the computation and dermatoglyphics patterns. So what we have done is will be the possibly we want to bring up some light, and we have to make a conclusion like whether it is possible to do it or not. Like we weren't trying to give a particular conclusion that it is possible to do the prediction. We were trying to prove that or we are trying to experiment that there is a possibility for a linkage between the dermatoglyphic patterns and the cognitive ability. So as an experimental procedure, we have taken these 212 sample space, and we have came to a conclusion that there is a possibility for this relation. So this is the like we have opened a door to such a stream where more research scholars and more there is a more possibility for research. so that more people can come and do the research. Maybe more people can get access towards more data set. Maybe institution where they have 4,000 people, they can get access to those their sample space more easily. But according to our constraints, we were only able to take this 200 sample space. We were just trying to open a new door to this particular research. So yeah, that's it.
Okay, over to you, Mahalingam.
Sorry, sir.
Okay. Okay. Oh yeah, thank you, Vinod sir. I evaluated them for the first round, so I asked 1 down 2 questions so at that time. So coming to what you have done after that. Okay. So your fingerprints, the ridges, the arches, these are all parameters to your model, right? One specialty to the fingerprint is they are claimed to be unique for each person, isn't it?
Yes.
So when you build these kind of models, you are starting off with some set of parameters that are unique to that particular person. So how do you actually, or how did you feel that something that is 100% unique to a person is essentially going to place him in a bracket of IQ range or into some IQ brackets? So can you explain that thought process a bit more? Because when we talk about IQ, we are talking about a range of values. The low IQ, medium IQ, and IQ of 10, 20, 180, 200, 300, 400, etc. And we are starting off with a value which is entirely unique. So how did you actually think of correlating both of them? Because I need to understand the thought process first.
I would like to answer the question.
Yes, please.
On coming to the uniqueness in the fingerprint, mainly if we all know that fingerprint is considered as the most secured biometric authentication. In that, we are using the pattern of arrangement of each curve in the fingerprint is considered as unique for each person. But here we are categorizing them according to the arrangement of patterns in each fingerprint, according to the rich count specifically in each individual fingerprints. For example, if an individual having low IQ, the occurrence of the word pattern will be more compared to other patterns. In coming to intermediate IQ, the occurrence of arc and word will be more compared to the loop. Loop will be one or two, or there will be no loop. On coming to high IQ, the person will be having more number of loop patterns on compared to other two types of patterns. So main thing, the arrangement of patterns in will be different in different set of IQ students. And also here we try to implement that the score, IQ score, the variation in IQ score in each of them will be different in case of, by comparing this variation in IQ score along with our fingerprint pattern, arrangement of fingerprint patterns in each individual. I think that will be the essential parameter how we can correlate between this IQ and dermatographic pattern.
Okay. So what you are just discovering is a stat. It is there, have you looked at any biological correlations? For example, the relations you just mentioned. The person with low IQ has more volts, I think. I don't remember the exact relation you mentioned, but is there any biological correlation which you found out after understanding that this particular pattern is happening? Is there, did you come across anything that substantiate this relation in a biological sense?
We had verified that if even this theory is true or not, because the arrangement of loops, arrangement of pattern is true or not. Exactly, the 171 students' hands were manually verified by us whether this idea is true or not. Because for collecting this fingerprint pattern, we had signed a consent from them. So in that consent, we had given a specific part to analyze what are the patterns that are specifically present in each individual to verify whether that side is also correct. So for that 171 individuals, we manually literally looking to their hands and verified that whether this theory is true or not. So yes, definitely we can say that there is a biological connection.
Okay.
Okay. Adding a point to what Sujit said, actually, the IQ of an individual depends on many factors. But for our project to consider as a best result, we took the fingerprint patterns to analyze the IQ. So it depends on other external factors also. But for our project, this was our main form to which we will get the results in the correct way.
Understood. Understood.
So just
Okay.
want to
Yeah.
add one more thing to this
Yes,
point.
go ahead. Go ahead.
So one of our base paper was done by a medical HOD, the head of the department, who worked in Trivandrum Medical College. So basically, what she have done is she have done this research on people who are having mental retardation, and she actually came to a conclusion that people who are having she took people with mental retardation and normal people, and what she came the conclusion that she came to is that people with world count, most of the world count in their finger, are tend to have more mental capabilities. So that's the exact biology and conclusion that she had did. So we were trying to implement that. If she is able to derive this conclusion manually, we are trying to build a computational version of the same.
Okay. Got it. Okay. Yeah, that's it from my end.
Sir, can we move to the demo part?
Yeah. Anupam?
Yeah, the team just mentioned that they have a demo of
Yeah, if it's small, you can quickly run through that. That's perfect.
Sorry, sir.
No, if it's a small demo, you can surely go ahead and
Yes, sir. It's a very small. I'll just share my screen right away.
Yeah, go ahead. Go ahead.
Is my screen visible right now?
Yes, yes.
Yes. So, give me a second, sir. So, sir, this is the type of data set that we have discussed a few minutes later before. So, for example, I'm taking the data set number 4. So here we have the name and student ID of those individuals, and we have the total fingerage count that we have manually calculated, and we have the IQ. So this is like we are mapping the dermatoglyphs variable to the intelligence quotient variable during our machine learning process. Just like this, we have around 48 data set, where the 48 dataset is a collection of total finger ridge count. This is the ridge count from right thumb, right index, right middle, right ring finger, right pinky finger, and the list goes on. And at the end, we have the arch count, the number of arches in a person's finger, loop, and goal. And finally, the IQ time taken for this particular individual. And this is the 48th dataset. So moving on to the code, basically, we have two code bases. The first code base is for the accuracy prediction. So I'll just run it right now. So basically what we have done here is we have loaded the data set here, and we have split into training and testing data set, and we have calculated the mean absolute error and root mean square error, and from those we have calculated the percentage of accuracy, and like we have came to a conclusion that the data set number 22 possesses an accuracy of 92.9 percentage in terms of mean absolute error for multiple linear regression. And just likewise, they have created a table of the accuracy possessed by each data set. And here it is the table which is showing that. And from those data set, we derived a conclusion that this is the data set, this is the table, or this is the particular thing where we have the best outcome possible to us. So basically, when it comes to linear regression and the combination of linear regression and mean absolute error, the data set number 22 has an accuracy of 92.9%. So while making up this table, we came to another conclusion that the best combination that we can get out of this research is that the combination of the combination of data set number 22. So the data set number 22 is a combination of total finger edge count, absolute finger edge count, arch count, loop count, ball count, which is mapped towards the IQ score of an image. And to verify the same, we have done the output prediction as well. We have another code base which do the output prediction. So for example, so here we have the data set. I'm removing a data set from here. So I'm removing the data set whose total finger edge count is 118, absolute finger edge count is 108. Sorry, I missed it. Okay, I'll take this individual. So the TFRC is 129, 157. The AFRC is 129. The pattern are 0505, and the IQ score is 56. So I'm removing this data from here, and I'm doing the computation. and we are entering the TFRC, which is 157, 129, 0, 5, 5. So what we have received is, according to linear regression, it says that the IQ will be around 50 to 30, 50.36. Decision tree says that it would be around 49, and random forest says that it is around 53.86. But actually, the IQ of an individual is 56. So this is one such example, and we are able to predict with such an accuracy around about 90% accuracy. We are able to predict this particular IQ of an individual. So this happens same with any of the inputs that we can do this right. So that's how we came to a conclusion that there is a possibility for the existence of a relation between demographics patterns and intelligence quotient patterns. That's it.
Okay, judges, do you have any further questions?
Nothing from my end.
Nothing. It's okay.
Thank you, team. Thank you for presenting. We will reach out to you with the further details via email. Thank you. Judges,
Thank
I'll
you, sir.
leave you
Thank
guys
you for the
to take out.
opportunity.
So actually, I would like to, on behalf of my team, I would like to say a closing note. So basically, the thing is that we have came so far because for the past 9 months, it has been a very hard journey for us because we have been working on manually collecting data. We've been manually counting all those data, and it is a great opportunity to be here and be qualifying to the final rounds. So despite of the results, this is a great opportunity for us. This is a testament to the work that we have done for the past couple of months. And our research wasn't focused on getting any kind of particular output. Our research was just to open a new door to more research scholars to do more research on this area where there is a less amount of researchers. So like this is a very inspiration to us, like or encouragement for us to do more kind of researches in this area. Probably we'll be continue doing upon this, and we'll be doing more parameters. We'll be working on this throughout our life, most probably. So thank you for taking this opportunity for doing this kind of events. And thank you, sir. Have a nice day.
Okay, nice job.
Thank you all.
Thank you.
Welcome back, Judges. I think we're still waiting for the next team to join. I think the time given to them was 7:45.
Are
so
they ready?
should-
Anupam, are they ready?
Yeah, they should be joining in a bit. We just reached out to them.
So then tell.
Yeah.
Nipam, the project is Rescue Wing, isn't it?
Yeah. The next one is Rescuing AI-powered disaster relief drone network from Mount Zion College of Engineering, Tamil Nadu. Judges, the team seems to be here.
Okay.
Yeah. Also, just note the project ID for the team is CSIN 2024-0401.
Okay. Got it.
Hi, Jagata. I hope I'm audible to you. Hello. Jagata, am I audible to you? Hi, team. I hope I'm audible to you guys. Ryan, can you confirm whether you can hear me? Judges, I'm audible to you guys, right?
Yes, yes, yes. You're audible.
Can somebody from the team respond? Jagata, Raghavi, Lakshya.
Hello, sir.
Yeah.
Can you hear me,
So,
sir?
yeah, I can hear you fine. I'm hoping this is everybody from your team and there's nobody left out.
Yes, sir. We are all the team members.
Okay. So, before we begin the evaluation, just some general instructions. You have a total of 30 minutes allotted to you guys. You can leverage the first 20 minutes for your presentation. That will be followed by 10 minutes of Q&A.
Okay,
And
sir.
I urge all of you guys to turn your cameras on and keep the cameras turned on throughout the entire course of the evaluation.
Okay, sir.
I will be taking a screenshot right now, so urge everybody to turn their videos on. Okay, good to know. Team, you can start sharing your screen.
Is the PPT visible, sir?
Yeah, it is. You can start.
Today we are about to present our project Rescuing AI-powered disaster relief drone network. I am Shranjan, and our team members are Mohammed Ryan, Jagada, Lakshya, and Raghavi. And our guide is Mrs. Sangeeta ma'am, and we are from Mount Zion College of Engineering and Technology. Okay, let's dive into the problem definition. When the disaster has happened in some area, there will be a multiple of challenges caused in that area. Challenges like uncoverable areas by humans and need of high human powers and unreliable communication and insufficient processing power. These challenges could result into the delayed response time, efficiency will be reduced, and the increased operational risk due to the critical disaster scenarios. The abstract is we have developed the AI-powered drones for autonomous disaster response. That is integrated with the advanced technologies like Raspberry Pi, Google Coral USB accelerators, and Mavlink protocol. It should be helpful in precise services in the rescue operations, and it has capabilities of the precise playload delivery. Because we are using Raspberry Pi, Google Coral USB accelerators, and Mavlink protocols, just like the advanced technologies. And we also developed our own Android application using Flutter, and will be user friendly for seamless communication and control. Our drone can be applicate in the disaster-stricken areas, humanitarian aid delivery, search and rescue operation, and military defense, just like that. Let's dive into the solution that are existing now. The existing drones has a reduced ability to cover large areas and cannot be used in the extended prolonged usage in the prolonged usage in the disaster scenarios. These existing drones are completely relied on the manual control, not full automatic. That may be a semi-automatic is available, but not fully autonomous. The existing drones just having a fully man controller that is controlled by a man. This causes a communication issue. See, if there is a transmission and receiving operation happening in the controller between the controller and the drone, a small communication disturbance or a communication latency will result in the serious problem in the drone. And using the complex existing drones have a complex coordination algorithm that will be slower response, that has a slower response times comparing to the fully autonomous one. The solution that we proposed are we developed the AI-powered drone system for a rapid disaster response and defense. I already said that the advanced components like Raspberry Pi and Google Coral USB, just like etc., are all used in this. If in simple, if I want to discuss about this, just if you want to load the package, just load the package in our drone, and through the Flutter Android application we develop, we can set the target location. We can set the target location and home location, and we can click the takeoff button in our app. This will fly the drone automatically and reach the target position or target coordinates, and wait for 30 seconds. Sorry, the 30 seconds is hard coded. We can customize the 30 seconds and drop the package. The package is dropped when the human is detected around the targeted location. If the human is present in the targeted location, the drone will automatically detect using the human detection algorithm we implemented and drop the package after 15 to 30 seconds or some seconds. This is hard coded. We can customize that. Just like it can be applicated in the humanitarian aid, search and rescue, and military defense. These are all the block diagram. The Python script are used in this Raspberry Pi. For the Raspberry Pi is a microprocessor which is act as a brain in our project. This is a central processing unit. This will has all the functionalities. We're using the Coral USB Coral USB is used for a process like high process like algorithm AI algorithm training, human detection, and object recognition are used in the Coral USB. Because Coral USB can speed compared to the Raspberry Pi. If we train all the AI algorithms in a single Raspberry Pi processor alone, it will be the response will be slower. With the Google Coral USB accelerator, we can implement all the algorithms in the Coral USB alone. This will cause the processing speed increase. Just like drone sends video to the data to the processing unit and Raspberry Pi, drone status will be updated to cloud database. We are using Firebase for this. And the AI and ML algorithm is used for human detection. I already said that if we click that if we input the target location in our developed app, Android app, developed Android app, we give if we input the target location in our app and the home location, we can the drone can fly to that location and detect the human in the target location and wait for some kind of seconds and drop the package, and and it is returned back to the home location that we input through the app. Methodology. Drone technology, leveraging advancements in the drone hardware, just like the Coral USB and advancements in the drone hardware and the flight control system. It's not manual. It's all about autonomous. So flight control are fully autonomous. Just we want to input the target location and the home location, and we load the package into the drone. This was the steps that are we used in this when we developed our drone. And communication protocols, artificial intelligence, integrating AI algorithm for human detection, tracking, and intelligent decision making during disaster response missions. We are implementing these AI algorithms to detect the human and drop the package near the human. If we didn't use the AI algorithm, it will just go to the target location and drop somewhere in that location. Tracking and intelligent decision making during disaster response mission. The decision making AI algorithm will decision make supposed to that environment and act like this. Communication protocol, employing Mavlink protocol with the drone kit Python. We are using Mavlink protocol with the drone kit Python for the efficient communication between the drones and the application we are developed. In a hardware, integrating the Google Coral accelerator and Raspberry Pi 4 for drone control and servo motor mechanism. Servo motor mechanism are used for the dropping package. Payload delivery depends upon the servo motor mechanism. This integration guarantees the efficiency, control, and the precision necessary for integrate operations of the drone fleet. For the user interface module, I already mentioned that we are developed a user-friendly mobile application with Flutter, ensuring real-time communication. Control application. If the application receives the input is transmitted to the Firebase, and the Firebase will transmit those inputs. Input means I am mentioning the height of the drone, target location, and home location to those drone. These are all fully autonomous, not controlled by a controller or anything. Drone hardware and AI integration. Develop AI enhanced drone. Uh, Already, this is also I mentioned that AI enhanced drone. This drone is full and fully AI enhanced with Raspberry Pi and Google Coral USB. Google Coral USB for fast transmission and fast data dealing. For human detection, integrating essential component Mavlink protocol. And we also developed the admin panel for target setting and home location setting for height purpose, package release, some kind of things. Technologies. We used Raspberry Pi. This is a brain of our project. This is a control unit, and this handles all the process. This integrate all the components in the Raspberry Pi. We integrate Google Coral USB accelerator. Google Coral USB accelerator work for the processing speed. It depends upon the fast speed. It depends upon the Google Coral USB. Google Coral USB provides the fast processing speed. as I mentioned that we are separating that AI task to the Google Coral USB and the remaining task to the Raspberry Pi. Because AI task will be fast processing in the Google Coral USB. If we integrate all those in a single Raspberry Pi instead of Google Coral USB accelerator, without Google Coral USB accelerator, the processing speed will be slow. Because we are separating these things. Mavlink protocol is the real-time data. We can get the real-time data and update to the database and the app through the Mavlink protocol, AI and machine learning algorithm. Autonomous navigation and decision making that we are using AI and machine learning algorithm. GPS and navigation system. GPS Neo 6 module ensures that we can get the accurate positioning of the drone and flight path management. Advanced sensor cameras. The cameras is used for the human detection and object recognition. Flutter-based Android application, user-friendly interface for drone management. All the inputs like height, home location and target location. These all inputs are given in the Flutter-based Android application that we developed. High efficiency battery system. We use the lithium battery that we can. This would be a high efficiency compared to those. Real-time data processing enables immediate analysis and response to changing conditions. These are the demo. It's an OpenCV project detecting the human and providing the boxes to the human. This is a package. It delivers the package just like this. It's go down. Drone will automatically go down, detect the human and go down and drop the package. This is our drone. This is the home location that we set for the drone through our Android app. For the future scope, we are just want to integrate advanced machine learning for obstacle avoidance. Just like if there is a bird flying around the drone, we want to use some advanced machine learning to avoid those birds and not alone the birds, obstacles that tree or leaves, anything from those. And pattern recognition, we are about to introduce the pattern recognition in this integrate advanced for the future scope. For the enhancing drone adaptability in complex environment. Swarm intelligence. Say if it is we have developed a single drone. If we develop multiple drones and able to connect with each other, we can seamlessly coordinate and increase the coverage and efficiency. It will save maximum of time because we are using multiple of drones, and multiple of drones will connect each other, and this will be efficiency in disaster response scenarios. In conclusion, the project is more concentrated on the autonomous disaster response and defense. This seamless communication between rescue teams and drones, along with real-time monitoring, will establish a real-time standard foundation for efficient disaster management. Navigating the convergence of the drone technology, AI, and disaster relief, this project exemplifies innovation in addressing crucial challenges. Thank you.
Can you show your architecture?
Yes.
Architecture diagram.
Through PPT, sir.
Yeah, your architecture, I think, because you are a blend of hardware and software. That's why I'm saying this to say.
Yes, sir.
Design.
Can I on the camera, sir?
Your design. That's what I'm saying.
Sir, can I on the camera and display our project, sir? It's ready. Can we show the drone?
Okay. Okay, that is your part. My question is your design. You are making a design first.
For designers?
Yes.
You're talking about a block diagram or?
Yes, block diagram.
Okay, sir. I will show it in the PPT. Is it okay, sir?
No. This is not the block diagram. This is a component you have used. The block diagram is called your project design. A design should be named there. Okay, okay. What are the various components you have used?
Coral USB, accelerator, webcam, and Raspberry Pi.
What is the resolution of your webcam?
So webcam will detect the human detection, sir. Human detection part.
Hey, Mahalingam, up to you.
Sir, I can hear you.
Yes. Yes.
Can you? Sir, I will show the video and my teammates will discuss it. Can I show some videos, sir?
Yes, please go ahead.
Sir, this is the servo meter used for implementing the package doubling mechanisms. With Raspberry Pi, we can set the angle for the sir. We can set the angle for the we can set the angle for the servo meter. Initially, it is set to zero angle. When we set to 180 degree, the package will be dropped, sir. The webcam is used to detect the human, sir. This is used to ensure that if there is any person to receive our package, using machine learning, we can detect the human. Coral USB accelerator is used to run the machine learning algorithm for detecting a human. It ensures that Raspberry Pi performance because it's run separately. And it is our drone, sir.
Okay, so what is the maximum weight you can carry with the drone?
The maximum weight is 400 grams, sir. You can carry.
So if you are talking about a relief operation,
we can develop it in future, sir.
No, I understand. Yeah, that I understand. So if you want to increase the capacity, how will you modify this drone? What all should be increased in the drone to increase the capacity of the drone? So tomorrow, if I want to carry 1 kilogram of material, what all should I change in this particular drone?
Sir, in future we are thinking about making the insulating more carryable. It can store 1 kg or 2 kg in future, sir. Now we have tested that it can carry 500 grams of the package. We have tested a first aid kit. In future,
That
we are
I
thinking
understand.
about.
No, that I understand. So if in future, since you are saying that you would make it carry 1 kilogram or something, what all changes will you make in that drone to allow it to carry the 1 kilogram? Because the same drone cannot carry 1 kg. So what
Yes,
changes will you make? What changes will you make?
Now we are using that. Now we are using the 4 propellers.
Okay.
In future, if you want to carry, if you want to carry 6 or 7 propellers, we use 6 or 7 propellers.
So if you use 7 propellers, the drone weight will also increase. So now your drone weighs the size of your processing unit plus 4 propellers. If you make it 7 propellers, your drone weight itself will increase with that 3 additional arms. So your drone is getting heavier and you need to carry more weight. So will adding propellers work?
Yes, sir. Just like the agricultural drone. Agricultural drone can be very bigger and have a 6 to 7 propellers, just like octocopter something, and that will carry a 5 kg or something. So.
Okay. So the bigger question becomes: can the same agricultural drone be used in rescue operations instead of building something new?
Yes, sir. This will be upgraded, sir. If we want to carry more kgs, we want to increase the propellers and make it possible, sir.
Okay.
Is it possible, sir? This is possible.
Okay, understood. Yeah. Okay, so that is it from my end. Yeah, go ahead.
For this prototype, we are using 4 propellers, sir. In futures, we want to increase the package weight. We want to increase the propellers.
Okay, understood. Yeah. Okay, so that's it from my end.
Any further questions?
Okay. Yes.
Sir, can I show the app, sir?
Yeah, we have 4 minutes. You can show the app.
Sir, basically this is our app. From here we can set the home location and target location for the app. And we can also add many more missions. We can set the mission ID. And the package type, we can the latitude, longitude, where the package need to be delivered. Then we can set the current mission to be executed by pressing this. We can see here the current mission that the ID will show. Then by using this takeoff button, we can start the drone, sir. And to ensure that the Raspberry Pi is connected, we can using this. And in this, we can set home location where the drone is to be sent, and we can view the home by maps, sir. And also view our target through map. These are the things we have implemented in the app, and we can also view the battery status of the app, sir. Battery status of the drone. Basically, if we want to set the target mission, we just want to add this plus icon and plus the mission ID and latitude and longitude for this and add the symbol. From the dashboard, we can click the takeoff button, so it will fly. Manually, we can set the height. So if the disaster is in the terrain areas, we can increase the height. This is the modes that are available. If the drone fly, it will be in the flying mode. Before the package delivery, the drone will be in a hold mode, and after that it should be in the parking mode.
Now if we want to set the home location, we set it to this, and we can view those home and the target location through the map in this setting. There is the time available for me. Can I show the assembled time lapse, sir?
I don't think that will be a problem because we saw the drone already. I think that's fine. We saw that.
Okay, sir.
Yeah.
Can I show the dropping view, sir?
Yes, quickly. Yes, quickly.
Now the target location, latitude and longitude are set it through our Android app, sir, and is in a flying mode. It goes for the target location, and it is in the hold mode. This should wait for the 30 seconds or some seconds. This will be hard coded. This will be customizable, and it will drop the package, sir. There is a servo motor in this, which will change the angle and will drop the package. Now this is return back to the home location, sir, that we set through the Flutter app. You can see that we didn't use the controller. We'll fly for the destination and it will reach the home automatically.
Okay. Okay. Yeah.
It automatically reaches it.
Okay. Yeah.
We didn't use any controllers.
Understood. Understood. Okay.
This video is setting the 4 waypoints, sir. It automatically goes to the 4 points and come to that same location.
Yeah, Anupam, I think we are out of time, right?
Okay, sir.
Yeah, we are out of time. Yeah. Okay.
Thank you for your valuable time, sir.
Okay. Thank you.
Thank you, team. Thank you for your presentation. We will reach out to you with the further details via email. Judges, I'll open the breakout rooms to you.
Okay.
Thanks for joining, team. You may now exit the call.
Okay, sir. Thank you.
Thank you. welcome back to this. Are we
Yeah.
ready for the next one?
Yeah, we are ready.
So the next team in is tuberculosis detection using deep learning models on microscopic images.
Okay.
And
Are the team ready?
yeah, the team is ready.
Okay.
The project ID is CSI in 2024-0535.
Okay.
Hi Shivansh, I hope I'm audible to you.
Yes, sir. Good morning.
Are we waiting for anybody else?
Yes, sir.
can
Just
see-
a minute. There's a problem for our teammate for joining the meeting. Just 1 minute.
Okay. Is that everyone? Or are there
Yes,
more
sir.
people here?
Yes, sir. We are two of us.
Okay. So welcome team, welcome to the final round evaluation. Just some general instructions before we begin. You have a total of 30 minutes allotted for your evaluation. You can leverage the first 20 minutes for your presentation. That will be followed by 10 minutes of Q&A with the judges. I urge all of you to keep your cameras turned on throughout the entire course of the evaluation. And I'll be taking a screenshot right now. Okay, so good to go. Team, you can start your presentation. All the best.
Yes, sir. Just I'll share my screen. Sir, I hope the screen is visible.
Yeah.
Okay. So, good morning, all. We are happy to present our project, tuberculosis detection using deep learning models on microscopic images. Now, let's have a discussion on the problem definition. So, tuberculosis is a serious and potentially grave communicable disease caused by Mycobacterium tuberculosis, a small aerobic non-motile bacillus. Every year, over 10 million individuals are still affected by TB. According to the WHO, the number of people newly diagnosed with tuberculosis in 2022 was 7.5 million, highest since 1995. 30 countries with a high TB burden represented 87% of the global TB cases, with two-thirds of these cases concentrated in the 8 countries across Southeast Asia and Africa. The same can also be seen from the graphs here presented, where the African region and the Southeast Asian regions have seen an exponential rise in the same. Currently, microbiologists manually analyze samples using a conventional microscope to detect TB bacteria across 500 fields. This process is inherently subjective, labor-intensive, and prone to diagnostic delays. Consequently, there is a critical need to enhance the accuracy and efficiency of the existing diagnostic system. This method of manual detection and counting of TB may miss about 33 to 50% of active cases. Thus, automated methods may help in increasing the diagnostic sensitivity since machines have the scope to screen a larger number of fields in a shorter duration of time, thus indicating a fast and accurate detection mechanism for timely diagnosis of TB.
Hello. Now we would like to talk about the proposed solution. In this study, we analyze and present two relevant object detection models for automated TB bacilli detection using the dataset consists of microscopic images of the field. First is YOLO V8 and second is faster RCNN. In addition, hyperparameter tuning was employed along with pre-processing of the images in the dataset to test this transfer learning approach based on the above model that had not been previously used for the specific object detection problem. This technique resulted in more generalized outcomes and higher mean precision value compared to previously recorded approaches, particularly with faster detection speeds. Finally, we applied a layer-wise relevance propagation, which is an explainable AI technique on the model with better MAP value to explain the individual classification and object detection decision in the sputum sphere images used. The LRP generates the heat maps on the model which indicate the voxel-wise relevance of a particular classification decision, thus succeeding in depicting individual contribution to TB diagnosis and how this approach might hold a greater potential as a diagnostic tool.
Our approach not only automates the mundane task of manual counting of bacilli, but also with the inclusion of XAI helps the lab technicians understand the role and significance of each voxel in the final output, which increases interpretability, transparency, and helps doctor make an informed and planned decision regarding the diagnosis of the patient. A comparative analysis with the existing study for tuberculosis analysis has been tabulated below, where our method achieves a higher precision than the studies before. Now, we look at the implementation pipeline of our project. So initially, a microscopic sputum image is given as an input. It goes through a pre-processing step where image augmentation techniques are applied, which will be discussed in the further slides as well. Then, paired with hyperparameter tuning, the model training takes place for two particular models, YOLO V8 object detection model, the first one, and the second one being the faster RCNN ResNet 50 model. Then, as an output from these models, we get the bounding box detection for tuberculosis, and the best performing model then goes through an explainable AI pipeline, which is layer-wise relevance propagation to give a boundary heat map image for particular image input.
The dataset was sourced from Macquarie AI Lab data website and comprises of 928 positively patched images. The dataset aimed to help diagnosis using readily available resources like contemporary microscopes and smartphones. The dataset comprises of images of fresh sputum samples with ZN stain magnified at 1000x and captured using microscopy and smartphone setup explained in their study. The expert laboratory personnel annotated the images, delineating the location of the bacteria by enclosing them within the bounding boxes. Across 928 images, approximately 3734 objects were annotated. On the bottom left-hand side of the screen, you can see a glimpse of the type of setup they have used for creating the dataset, and on the right-hand side of the screen, you can see the samples from the dataset. Each image within the dataset contained two types of patches. First is positive patch and second is negative patch. Positive patch contains actual bacilli or the cluster of the bacilli. The negative patches are the one which contains artifacts such as blood cells or impurities. To maintain a balance between the number of positive and the negative patches, two measures were implemented. First is random discarding of the negative patches. Negative patches were randomly discarded to ensure that they were at most 100 times the number of positive patches. This step helps prevent an imbalance in the dataset. Second measure which we have taken is creation of new positive patches. New positive patches were generated by applying all combination of rotating and flipping. This augmentation technique increases the diversity of positive patches while maintaining the balance with the negative ones. On the right hand side of the screen, you can see on the top there is the type of image you will get by after applying a vertical after applying a horizontal flip, and on the bottom you can see the type of image you will get after applying a vertical. For model compatibility, the images were resized to a resolution 14 to 640 pixels. Subsequently, the 20% for validation and 10% for testing. Image augmentation techniques like horizontal and vertical flips were incorporated. This approach ensures that model is exposed to a variety of orientation and perspectives, thereby improving its performance across different scenarios. Consequently, for both the models, YOLO V8 and faster RCNN were trained to give the best possible result using the higher parameter tuning. In the tables provided below, on the left-hand side, we can see the type of hyperparameters we have used for both the models in a study. And on the right-hand side, you can see the performance of both the models across different metrics. Here, we can clearly see that YOLO V8 is giving better performance as compared to faster RCNN in both the matrices we have used.
Now, explainability plays an important role in ensuring transparency and interpretability of a model, thus instilling confidence in the results by highlighting attributes that contribute to how the model arrives at a decision. A powerful method to achieve this is the layer-wise relevance propagation, which decomposes the network's output score into individual contributions of input neurons while keeping the total amount of relevance constant across all the layers. Here, heat maps rely on model parameters that are weights and neuron activations to highlight the regions. On application of LRP, we obtained heat maps outlining the bacilli structure. This gives a deeper insight of the model decisions and which components in the original input play an important part by distinguishing an object from its background, thus generating heat maps explaining the detection made using the model. The same can also be seen from the image put on the right, where an original image has a corresponding explanation for the TV class, where heat maps have been generated for every area of interest.
Not talking about the technologies which has been used in making this project possible. First, for the object detection pipeline, the technologies used are like object detection libraries like your family of models as well as faster RCNN. For explainable AI, we have used layer-wise relevance propagation, image processing robot, and in journal libraries like PyTorch, TensorFlow, Easy Explain has been used. Our approach has been trained and tested on Google Colab using A100 GPU. Besides this,
Yeah. So now discussing about the future scope. First, one of them is integration with other diagnostic tools such as multimodal learning. We can look forward to combine microscopic image analysis with other diagnostic data, for example, chest X-ray or other clinical data, to improve overall diagnostic accuracy. It can be complete a diagnostic tool which can be used with any type of TB image, that is a sputum, for example, which we have utilized in our initial study, an X-ray or a CT scan. Another can be expansion to other diseases for object detection and classification. One application can be kidney stone detection, where we apply similar transfer learning methods to detect kidney stones in X-ray images. And another classification problem which we can see is brain tumor classification, where we can adapt transfer learning based classification system for identifying tumors in brain MRI image, for example. Our approach is computationally lightweight, which can be easily deployed as a mobile application or as a web hosted platform, which can be expanded to various use cases as mentioned above, thus making it a one-step automated preliminary diagnostic tool for multiple diseases in resource-constrained settings.
we are happy to announce that we have expanded our initial proposal and is able to include majority of the promises we have made in our future works, which include inclusion of various diseases varying across different tasks like classification or disease prediction as well as bounding box detection. Now we would like to move towards a demo.
I hope my screen is visible.
Yes, it is. It's showing the presentation, right?
Yes, sir. This is the
Yeah,
demo of
yeah.
the entire web application.
So we are able to see the slide. We are able
Okay,
to see
just a
the
moment. Just a moment. Just a moment.
yeah. Okay.
Is it visible now, the website?
Yes, a Versal app, right?
Yeah.
Okay, yeah, that's.
Now, first, we would like to give you a demo of the disease prediction pipeline which we have created for this.
So here we'll be exploring a brain tumor classification, which is a simple classification technique. Which what we'll do is we'll classify various types of brain tumors. So for example, here I give an image of a tumor. Let's take, for example, a glioma tumor, which we can give to the website. And we have uploaded the image. Now we'll submit it. Now it's going to take some time for processing. It's a globally hosted website. It's not running on a local systems at all. So it inferences from model weights which were trained during the classification process, it is utilizing at a backend a simple CNN classifier, which was trained on through transfer learning on ImageNet dataset. So we'll give it some time to process and give us a result on the brain tumor classification it determines. So as we can see, it has correctly identified it to be a glioma tumor, and the confidence is also pretty high, which is 96%. So that's pretty good.
Now we would like to give you the demo of the main crux of a project, which is object.
Yeah. So here we'll be giving you a demo of the same tuberculosis project which we have done on the initial stages of this pipeline. So here we'll upload a tuberculosis image. A sample sputum microscopic image is being uploaded. Now I'll submit it. Now this is again going to take some time for processing, given it is hosted globally, and also it is an object detection pipeline, so it's a bit more heavier compared to classifier. And now we have an image pretty fast. We have the object detection bounding boxes created across all areas of interest of which can be the tuberculosis bacilli with various confidence scores. Now, when a lab technician is using this tool, they can obviously modify the confidence scores to get only detections for that particular corresponding confidence scores. So another feature which we have implemented here is a chat with AI feature, which is something which we have explored in a different domain. So here it is a medical assistant which helps us answer various medical queries. For example, we figured out a glioma tumor in our classification problem. We can ask what is a glioma tumor, and it's going to give us a response. So this is a response for any casual user who comes across and wants to know certain stuff about the classification result which they got from our tool. Another important feature which we have utilized is optical character recognition. So here, for example, when we go for a blood test report, for a blood test, and we get a report, what we can do is we can upload this report and we'll say, which deficiencies does the patient have? So it's going to take some time to inference from the reports. I'll show you the sample report which we are using now. This is a simple common pathological report which generally we get after a possible blood test. So here the model, the chat bot has already given us an answer here that, okay, the anemia level, so the hemoglobin level is 11.4, which is below 11.5. So possible anemia. So there are various other inferences can also be taken from the same. Now, another prompt which I can give, which can be a general user query, would be, what all remedies I can adopt to mitigate these deficiencies. So again, it will infer from the results it has provided before and the pathological report in hand. It will take model inferences, it will understand, it will get data from everywhere. And here we have, again, it said hemoglobin was less, so it has told us to take vitamin C intake, citrus foods, bell peppers, iron-rich foods, same for WBC count, neutrophils, and so on. So that ends our demo of the project.
So why you are using these two different models like YOLO and other models?
Yes, sir. So two models, two were used for object detection.
I think a pretrained model can identify these things.
No, sir, definitely. So both models were used for experimentation purposes, the YOLO model and the faster RCNN model. So we figured out that for object detection task, YOLO model is way better than faster RCNN. So it was an experimentation part. Final inferences on the web application also is from the YOLO model itself for object detection technique.
No, my question is, even you, faster RCNN is sufficient for that.
Yes,
YOLO
sir, I agree. Faster RCNN is better, and in our comparative analysis also, there are. That's why we chose the two best object detection models, which are faster RCNN and YOLO. Now we applied YOLO because from faster RCNN, it was seen from the data presented in our PPT as well. The YOLO performed better than faster RCNN, and given that YOLO is being adopted more for hosting on web applications, it's a bit more lightweight. So we adopted a more latest technique, which was YOLO. Faster RCNN also works better in object detection, but as for the metrics presented in the PPT, the accuracy and the precision was, and the recall even was better than YOLO V8 model.
So you are after that you are just use explainable AI. Which app is you are using for that? ChatGPT?
No, sir. So the explainable AI part, the heat maps.
Not developed, or you just used some components?
So the chatbot.
Yes.
Yes, sir. So the chatbot, we are not using ChatGPT. ChatGPT is a commonly trained model for everyday general knowledge purposes. So it may not understand and interpret medical jargons very well. So we have utilized the fine-tuned large language model based on Llama 3. So there, for example, this all models are trained on various medical data sets itself, whereas like Stanford medical data, USMLE data, and PubMed journals data. Maybe Rohit could also add something to it.
So over to you, Mahalingam.
Yeah. Okay, so now we have you started off with a tuberculosis model. Now you expanded to many other domains as well. So when you are you using the same model for all of them, or do you have any custom or fine tuning done for each particular disease?
Again, using a generalized model for all diseases would not be a very good practice. So what we have done is for object detection, which is a bit more complex task than classification. For the tuberculosis, the pipeline is pretty much settled. So we have also put out a paper on that. The same for other two diseases which we have shown on the web app, which is kidney stone. So the kidney stone one is still under development. We are able to get good accuracies from present normal classical CNN models, but we still want to improve it. But for image classification, every image classification is using a different pipeline, and it is a bit more easier problem compared to object detection. So every disease will have its own model parameters and hyperparameter tuning, which is separate, not dependent on each other. Because again, characteristics of artifacts differ on each image.
Now, talking about the object detection, even for the actual objects, you are using separate fine tuning, isn't it?
Yes, sir. So for tuberculosis bacilli, we got the data set where we have annotations for the bacilli. So we applied hyperparameter tuning for about a month or two, where we kept on getting experimentations done as to what can be the best accuracy we can get from this data set. Okay. So that was done for tuberculosis. The same is being performed at this stage for kidney stones and brain tumor object detection also.
Okay, so what's the size of the data set you use for training all this?
So the initial data set which we got had about 1200 images, out of which 928 were positive. Like 928 had the TB bacilli data set, like TB bacilli in it. Then we applied image augmentation techniques and increased our data set to about 1500, 1600, sort of that.
Okay, got it. Yeah. Okay, yeah, that's it from my end.
Anupam?
Yeah. I hope there are no further questions, and we can move ahead to the evaluation discussion then. So thank you, team. Thank you for taking your time. Thank you for doing the presentation. We will reach out to you with the further details via email, like we used to. Thank you for joining. Have a great day ahead. Thank you.
Thank you, sir. Thank you.
Judges, I'll open the breakout rooms.
Okay.
In the next presentation is only on 11:15, correct?
Yeah, so we've contacted, yeah, we've just reached out to them.
No problem. If the student is ready.
Yeah, we've reached out to them. They said they'll be joining shortly, so we should be able to get this done without a tea break. Yeah,
Not
when
ready?
is the next? They are yet to join. They should be in shortly. I'll just check again from my end. Judges, the team has started to join.
Okay.
So the next team in is Smart Wasteville from Mar Basilius College of Engineering and Technology.
Yeah. That's it.
And judges, please note the project ID is CSI in 2024-0392.
Okay.
Yeah, hi team, I hope I'm audible to you.
Yes, you're audible.
Yeah. So just want to know whether we are waiting for anybody else or is it just going to be a question?
Give us 1 second. One more person is joining.
Brian, I can see somebody with the name Abraham maybe in the waiting room. Is he the one that you're waiting for?
Yes, yes. He's the one we are waiting for. Could you let him in?
Yeah.
Yeah.
Okay. So I hope we are good to go, right? It's three of you here.
Yeah, three of us.
Right. Okay. So some general instructions before we begin the evaluation. You have a total of 30 minutes allotted for your evaluation. You can leverage the first 20 minutes for your presentation, post which you will be going through question and answer session with the judges. I urge all of you to keep your cameras turned on throughout the entire course of the evaluation. I'll be taking a screenshot right now. Okay, we are good to go. Team, you can start your presentation.
Hello, am I audible?
Yes.
Vince.
Okay, I'll share the screen with you.
Okay, so yeah, I'll be starting the first phase of this presentation. So welcome everybody to our presentation. This is our topic, smart waste bin. Next slide, James. Yeah, so I'll just tell about like a brief problem statement which we are trying to solve here. So the first problem which comes in India especially is India and worldwide especially is while dealing with waste segregation, we are still using like you would say like older methods. We haven't implemented technology in it yet. So most of the places, as you have seen, there are like just separate bins kept for like each different sources, like biodegradable, non-biodegradable. What we are trying to do as computer science students is integrate technology to this. Like how could we make this waste segregation faster? And coming to India, one of the big issues is like if you are mixing these two waste sources like biodegradable and non-biodegradable, it can lead to many problems, especially when it comes to recycling. And it's also a big threat to our environment. And we are also in this project, mainly what we are trying to do is create a model. Next page, please. So basically what we have created is like a smart waste bin. So what it does is, while you are putting the waste in, it segregates into two components, biodegradable and non-biodegradable. Biodegradable waste are kept as one portion, and inside non-biodegradable, we are again segregating into metals and non-metals. As you could see in strategy one, mainly there are two compartments, biodegradable and non-biodegradable. This segregation, initial segregation, is based on image processing. We have kept a camera inside it, and we also have a image processing model which segregates into bio and non-bio. The second segregation, which happens at the non-biodegradable part, is into metals and non-metals. That is done through just metal sensors. And also, along with this, we are also judging the depth of the bin. So basically, when the depth increases or reaches a certain threshold, alert is sent to the local computer so that waste collecting authorities can go and collect the waste. And also, we are also taking pictures of these already segregated waste so we could improve the model in a way. Abraham would be saying the next.
Am I audible?
Yes.
Okay, so this is basically the implementation of the model. So as you can see, on the left is the overview of the hardware model, and on the right is a detailed view of the hardware model. So as Brian had mentioned, in this waste bin, the segregation of the waste is being done primarily at the source. So, as he had mentioned, there is two primary segregations. Two segregations. One is the primary and the secondary. On the primary, when a waste is being dumped uh, through camera, as when the bin when the bin basically captures the image after sensing that the waste has been dumped, it will be sent directly to the Raspberry Pi, in which we have implemented a trained AI/ML model, which has been trained over a set of images and data, which will be able to understand whether the image or the waste that has been dumped is biodegradable or non-biodegradable. And based on that, the segregation is done. And three compartments is being present in this waste bin, basically biodegradable, metals and non-metals. And if it is a biodegradable waste, it will fall directly into the biodegradable compartment when the flap opens. And if it is a non-biodegradable waste, then with respect to the other flap, when it opens, it will go to the secondary segregation. And thus, in the secondary segregation, we have implemented metal sensors underneath the flaps to detect whether the waste of non-biodegradable is metals or non-metals. And based on that, it will segregate into metals and metal compartment or the non-metal compartment. And after the segregation is being done, the depth, as he has mentioned, would be analyzed as we have implemented the IoT sensors, that is fill level for each compartment, and the gas detection sensor for the biodegradable compartment for detecting whether any harmful gases is being formed, such as methane or carbon monoxide. And parallel to this, we have also implemented a web application in which the data, including the image, the timestamp, and the fill level sensors of each compartment and the gas sensors, everything is being analyzed and being put as a data visualization to understand to analyze how much of the bin has been filled. And if there is any harmful gases present, then we will send an alert message through the web application that it can alert the garbage collector or the municipal corporation to collect the waste as soon as possible. And over to the next slide. So as part of this, we have implemented, yes, automated segregation, and altogether this waste, we are not at all controlling. It is being done as an automated segregation for both the biodegradable, non-biodegradable, and for the segregation of the secondary waste. And two-level sorting is being done as to primary and both secondary to understand whether the waste which we have collected is biodegradable, metals or non-metals. Then and also the image-based classification of the AI model has been 84% accurate. So through the accuracy, we can understand that, if we put more data, and we can actually make it a better model for giving more accuracy and for displaying the images. And the sensor triggers is being used. IR sensor is being used at the starting, so that when an image is being dumped at the starting, it senses that the image is being dumped, so that the camera could turn on for capturing the image for the processing of the AI/ML. And the gas monitoring sensor also is being used in the biodegradable compartment for detecting harmful gases. Next slide. Yeah, so this is basically the overall architecture, that the Arduino Uno R3 is a microcontroller that we have used for connecting to the various sensors, and for the servo motor bins, servo motor that is being used to connect to the flaps. So servo motor is being used for opening and the closing of the flaps, and the level sensors is being used. Next slide. So this is over to Jens.
Good morning, everyone. So the implementation, the rest of the implementation of the smart baseband. The fill level detection. It's basically, there are three compartments in this. As Abraham said, there's the biodegradable part, the metals, and the non-metals. So for each compartment, there is a fill level detection using the IR sensors. Inside the biodegradable part, there are seven IR sensors, and for each metals and non-metal compartments, there are 5 IR sensors. And these IR sensors convert the fill level into a percentage, so that after a particular percentage, like after about 90%, it will give an alert message to the concerned authorities. Then there's the data logging. So we have used the Arduino Mega and the Raspberry Pi 4. The Raspberry Pi 4 is where the image processing and the where the image is being captured. So when the image is captured, it goes to the AI ML model, and that model identifies it whether it's a biodegradable or a non-biodegradable part. And after the whole process, that image is then diverted to the corresponding folder, which is the biodegradable or the non-biodegradable folder. And after a week or so, it can be the reinforcement learning can be implemented. That is, these captured images can be used for further training the model, and that model can be made better and better every week or so. Then it's a durable design. That is, this is made using acrylic and foam wood, which is almost the best in this segment, and so it has high durability and usability. Future upgrades. So here we are referring to more than one model. So if we create like 4 models across 4 different cities in the same district, 4 different cities, when any of the compartment has almost filled up to a level, or there are high toxic fumes in any of the waste bin, there will be an alert going to the corresponding authorities. So after that message goes, it automatically routes the shortest map to the waste bin. So that is using the GSM modules. So this is the basic workflow of the smart waste bin. As I said, the physical model contains the Raspberry Pi. Raspberry Pi has the camera connected to it, and the MQ2 sensor is for the toxic fumes. That is, high toxic fumes like alcohol content or methane content. It can be highly inflammable. So that's why the MQ2 sensor is being used, and the PIR sensor. Those are actually the fill level sensors, and the Arduino Mega is being used. Arduino Mega is for controlling the sensors and actuators. That is the hardware part of it. This whole project, this whole bin can be classified into 2, like the hardware part and the software part. The hardware part is mainly controlled by the Arduino Mega, and the software part is basically controlled by the Pi. And so, as you can see here, the model, the image processing model, which we have trained using the available data sets from the internet, and so that model is being loaded into the Raspberry Pi. That is where the whole processing takes place, and where the instruction is being sent. So then we have the IR sensors. IR sensor is for, as I said earlier, it's for detecting the fill level. Then the magnetic read sensor. This magnetic read sensor is the first sensor that is to be triggered when the lid opens. That is, when we push the base inside, the lid opens. Yeah, so where I show this, the push section there, that lid opens. So when that lid opens, this magnetic sensor, read sensor, gets triggered, and this trigger goes to the Raspberry Pi so that the Pi camera will take a picture and the rest of the process continues. So then we have the Pi camera, as I said earlier, for capturing the images. Then metal detectors. Metal detectors is for the secondary segregation. Secondary segregation, I'll show. Yeah, this is the secondary segregation where we have the metals and the non-metals. So for that segregation, we have the magnetic sensor. Now we have the gas sensor. Gas sensor is, as I said earlier, it's for detecting the harmful gases or the toxic fumes. Then the capacitors, jumper wires, and battery. These are the hardware part. That is, we have used the Arduino Mega. So for the mobility of the compartments, that is, the lids of these compartments should be moved. Then only these waste can be segregated. So those mobile sections, they use these capacitors and all. So they need battery backup. That's why these capacitors are used, and for the connections, jumper wires, etc. Then acrylic blackboard and foam board. As I said earlier, it's for the structure of the build. Yeah, so the video for reference I'll show. Yeah, so now we have the website. Yeah, so this is the website that we have created for the front end part of this project. As you have seen earlier, this is just a description, but this analysis. So this is the first analysis that we get, that is the biodegradable and the non-biodegradable. As I said earlier, when the segregation, the primary segregation happens, we have the Raspberry Pi. It is almost like a mini computer. So that's where these things are stored. And inside the Raspberry Pi, we are logging it into a CSV file. This CSV file is transferred to a local computer using SFTP, that is the Secure File Transfer Protocol. So using this SFTP, this CSV file can be retrieved within like an interval of time. We have set it as 1 minute, and so we can set it as any minutes. So we got the first analysis of the number of biodegradable and the non-biodegradable waste. Next, we have the fill level sensors. The fill level sensors are always on. Like when we have a waste going inside any of the compartments, during one whole cycle, every part of it works. Like the fill level sensors work, the Pi cameras work, the toxic fume they work. So all these sensors work for one time in one cycle. So that's when we have a log when we have one waste logged into the CSV file, we have the corresponding fill level sensors of the 3 compartments also logging into it, so that this CSV file can be retrieved into our local computer, and this local computer has the website in it. So this website takes this CSV file and shows it using Chart.js and JavaScript. So that's how this is used. Now we have the gas detection sensor, that is the toxic fumes or the harsh gases that is present inside. So this is uh, the chart that depicts which waste had the highest uh, content of toxic fumes inside that compartment. Yeah, so this is the number of the overall description of it. And here we have the location currently here, but this is for future scope. That is, as I said earlier, when we have more than one bins deployed, it may be spread all over the city. So it, with the help of the GSM module, we can have the shortest path retrieved, and the corresponding authorities can go to that place. Yeah, so that's it. Future scope.
Yeah, so basically coming to the future scope, there is a lot of advancements we can basically make for this project, starting with for the machine level model, AML model. If we wanted to increase the accuracy of the model, we can a part of a way which we have thought that if this is possible is by the image which we capture of each waste. And suppose in case we are keeping it on a place, an environment for a couple of week, 1 week or so, the image of each waste that is being captured, it can be stored into a folder, and then afterwards it can be used for again training the AI/ML model and thus increasing its accuracy and making it a better learning AI/ML model for better segregation of waste. And also another way of we could do is by which we have thought on, but basically it's a future scope of this project is by using cloud. So we could use cloud for, where we could integrate this AI/ML model so that multiple data could be stored of each waste, and more efficient storage system we would be able to get, and it would be able to predict. And also we can also incorporate various predictive algorithms based on the analysis and use for various methods for and find out the waste patterns and other recycling opportunities which we can do for the plastic waste that is being uh, segregated and like present and deposited in that compartment. And also we can incorporate several environmental sensors for measuring the air quality and the temperature around, so that it could increase the environment's efficiency and make it as for increasing what we call for a smart waste environment. That's all. Thank you.
Okay, what may be the cost of this one product at present?
At present, it's actually 40,000, but that's because we have taken the Arduino Mega and the Raspberry Pi. That two compartments makes up a lot of this cost, because if we are going for a future scope, that is in a large scale part, this can be integrated into a single chip, this whole process. But we were actually researching on our topic, and so we had to uh, purchase these products. That's why this cost.
You didn't answer, but how much is the cost? Maybe in future, what may be the cost, maximum cost? Otherwise, you keeping this bin in a locker if the cost is very high. If the cost is that much high, that bin should be stolen.
Yes, that's understandable. But from what Jinsen's mentioned, if we are able to scale it in a large scale method of, then we could actually create a small chip which can be programmed. So, and thus we need not have to, you know, use like much of the cost which we had at the starting of the project. So it could vary around based on the technology that is being used and the systems. It can comparatively it will be more way lesser than how much it was originated. It totally depends on the technology and the sensors that is being used.
Okay. Over to you, Mahal.
Yeah. So when we talked about this in the previous rounds, the question that came was, how about a plastic potato? Remember?
Yeah.
So is there a conclusive answer for that now?
Actually, our model uses a lot of layer detection, and this particular question was raised earlier also.
Yes.
So for that, we have these feature extraction layers inside this ML model. So when you take the original potato and the plastic potato, there's the difference in the features, like the tactile features. So this is actually able to understand the or retrieve the features from the image capture. So that's how it can be distinguished.
Okay. Is there any measurement regarding the weight of what is being put in that particular bin or anything? That is because typically a bin can carry a maximum capacity. So if I just keep dumping, even if it is half full, I can dump it with bricks and it will still fill up really quickly, or it will be really heavy in size. So is there any such measurement also coming into the picture when you look at the bin filling rate? If the bin can accommodate 50 kg, it should stop at 50 kg, right? It should be emptied after 50. So is there any such measurement that can be incorporated into this bin at any point of time?
Yeah, it can be incorporated, but as of now, it's not there.
No. If it is to be incorporated, will the hardware be sufficient? Will you need additional hardware or
Yes.
anything? The weight plate is there. Weight plate is fine. To perform the computation, do you need anything extra?
No. Just the weight has to be taken off.
Okay. Okay, yeah, that's all from my end.
Anupam?
Yes, sir. I hope we are done with the questionnaires. So thank you, team. Thank you for taking your time to do the presentation. We will reach out to you regarding the further details via email. Once again, thank you for presenting. Have a great day.
Thank you, sir.
Okay.
Thank you.
Thank you.
Thank you.
Welcome back, judges. That was the last session of the day for us. So with this, we have come to the end of 13th edition of CSI InApp International Student Project Awards 2024, where we witnessed numerous projects encompassing a wide array of technologies and domains. As the final round evaluation schedule comes to an end, I want to express our heartfelt appreciation to the esteemed judges for generously sparing their valuable time in their busy schedules to be a part of the panel and evaluate the projects. We would greatly appreciate it if any of the judges could share their valuable comments, feedback, or general insights on the sessions.
Basically, there is a quality is very comparatively very little bit. That is why our mark that will reflect in our marks also. That's a thing only we can say.
And Mahavingam, you've been part of the panel for multiple rounds now.
Yeah. No, as Vinod sir said, when we say quality, it's about, I'll say, the lack of innovation and lack of depth. It's not like these are not irrelevant or it's not useful or anything, because it's more like there's something we face from the industry perspective as well. We get code really easily. We get these LLM models to give us answers very quickly. So there had been a huge number of projects that simply leveraged this instead of coming up with some innovative research. So that was something which we kept on seeing throughout the rounds. At least in the finals, one thing we have to appreciate is most of them have done good work. Okay, they used the support of all these tools. That's acceptable, but they have done fair amount of work, and thankfully the entire set of panels that helped us filter this did a really good job of filtering into the last 9. So we felt that the effort was worth that. And finally, we have selected the top candidates, so which we can publish later. Yes.
Yeah. Once again, thank you, judges. Thank you for taking your time to do this. The final round's results and specifics will be made available on the website. Additionally, I extend my gratitude to all the finalists as well as those who actively participated in the live sessions. Thank you once again to everyone for making this event a success. Have a great day.
Thank you.
Thank you. Thank you.
Thank you.